In this video, we're going to look at ionic formula and how to write ionic formula for a whole range of different ionic compounds. So in the last video, we talked that an ionic compound was a combination of a cation and an anion. So the example we used last time was sodium chloride, where we have sodium ion being our cation and chloride being our anion, and they come together to form sodium chloride. Now, sodium chloride is one of the simpler ionic compounds that we have around, but there's a whole range of different ionic compounds that are out there. For instance, we have something like this, ammonium phosphate. And if we have a look straight away, we can see this is a lot more complex and probably a little overwhelming for us just when we're starting out. So we probably need to go back a few steps and try and figure out the best way to write ionic compounds and ionic formula. So let's look at a whole range of commonly encountered cations. What we have here in this table is a bunch of simple cations. So some of those are things like nickel and potassium. What we see is they are just charged elements. We also see that there are some elements that have different charges. So for instance, iron 2 and iron 3. They have a charge of 2 plus and 3 plus respectively. And we have what we call a complex cation, which we've circled here in green, which is ammonium. And this isn't a charged element, it's actually a compound that has a charge with it. So it's nitrogen with 4 hydrogens, and it's given a charge of +1, and that's its structure that we've just drawn there. And we can see a similar sort of thing with our anions. So here we have a list of common anions. And just like our cations, we have some simple anions, which are just charged particles like bromide and iodide. And we have a whole lot more complex anions. So an example of one is something like hydroxide, which has 1 hydrogen and 1 oxygen, and it has a charge of -1. Or we could have something like carbonate, which has 1 carbon and around it, it has 3 oxygens. So you'll notice with our complex anions and cations, it's always written that the number of a particular element in the ion is the subscript and the charge of our ion is the superscript. So that's why it's CO3 2 minus. So those are the anions and cations. Now we need to talk about how we bring these together to form ionic compounds. So here are some rules. The first is we always write our cation before our anion. The next one is that ionic compounds are electronically neutral, so we need those charges to balance out. And the final rule is multiple complex ions need to be contained. And I'll go into what that means in a bit. So the best way for us to learn about how to write ionic compounds is to do an example. So we've got this example here, which is write the ionic formula for magnesium hydroxide. And using those rules we've just seen, we're going to try and put this together. So cations before anions. So what we notice straight away is that the way our ionic compound is written is the same order that our ionic formula will be written. So we write the formula for magnesium ion, Mg2+, and the formula for hydroxide, OH-. The next rule is charges need to balance out, and we can see straight away that magnesium has a charge of +2 and hydroxide has a charge of -1. So we can't just put these ions together. They need to be balanced out. So what we do is we bring the charge from the hydroxide down to our magnesium, and we'll do the same for our magnesium to the hydroxide. So when we do that, we bring the 2 down next to that hydroxide. And so we've combined those two uh, ions together, and it looks like we're pretty happy with that as MgOH2. But the final rule, multiple complex ions need to be contained. Now, what do I mean by contained? Well, I'm not going to stick them in a glass case of emotion. They need to be bracketed because if we have a look at what we've got here, MgOH2, that's the same as writing MgH2O. There's no difference. It's telling us we have one magnesium, one oxygen, and two hydrogen. And when we rearrange that, that's saying magnesium water, which is not what we were wanting to write. We were wanting magnesium hydroxide. So when we mean contained, we need to draw brackets around those complex ions when we have multiple ones of them. So we now write Mg in brackets OH2, and then this gives us our ionic formula for magnesium hydroxide. Magnesium hydroxide is a key component in antacids, so if you ever had heartburn, magnesium hydroxide would have helped you out. So those are the rules for our writing ionic compounds. If you use those rules, you can write any ionic compound or ionic formula that exists.